Today we're going to be talking about the different types of chemical reactions there are. By the end of the lesson, you should be able to identify each of the different types of reactions and be able to explain what happens in each of these 6 different types of reactions. As I stated, there are 6 different types of reactions. We've got synthesis, decomposition, single displacement, double displacement, combustion, and neutralization. In the next slides, we are going to be breaking down each one of these, talking about what happens, giving you sample equations and generic equations to help you make it easier to identify each of these types of equations. So the first one is synthesis. This is when you have 2 or more reactants that are combined to form one product. Remember, reactants are what go into the equation, they're on the left side, and products are what come out and they are on the right. So looking at this generic equation here, we've got A plus B, which makes AB. So this is what we're talking about. We've got 2 or more that have come in, the A and the B. They are now combined and formed the one product of AB. Another example would be 8Fe plus S8, which makes 8FeS. Now let's talk about decomposition. This is the opposite of synthesis. It takes one reactant and breaks it down into 2 products. So we've got AB as a compound, the only thing that's coming into the equation, and it's being broken down into A and B separately. So AB is being pulled apart and separated into an A and a B. An example of this would be if you're taking water and you are breaking it down into its different hydrogen and oxygen components. Another one we are going to be talking about is single displacement. This is when one element in the reactant trades places with another to form a different compound in the product. So we have a single element all alone by itself with a compound here, and as they go through their reaction, they end up coming out as switched. So the C went and bonded with the A, and the B came out by itself. So that is what we mean when we're talking about them trading places. The element that went in as a single component is not what is single as it comes out. We have an example down here with zinc and copper chloride. So zinc plus copper chloride ends up creating zinc chloride and copper on its own. The chloride goes and bonds with the zinc, and the copper ends up being kicked out to be by itself. Now let's talk about double displacement. So this is when 2 elements of the reactant trade places with each other to form different compounds in the product. So this is when you have 2 compounds that come into play on the reactant side, and the anions, remember those are the negatively charged ions, the anions and cations end up switching with each other so that they are paired differently in the product. If you look at our generic equation here, we've got AB plus CD makes AD plus CB. So the D and the B ended up switching places. Looking at this other example here, we've got magnesium oxide and calcium sulfide. Magnesium oxide plus calcium sulfide makes magnesium sulfide plus calcium oxide. So the oxygen and the sulfur ended up just switching places. Now let's talk about neutralization. This is when an acid and a base react to form water and a salt. So the acid is anything with an H+ ion, the base is anything with an OH- ion, and the salt is going to be an ionic compound. So remember from ionic bonding, the ionic compound is going to have a metal and a nonmetal bonded together. So our generic equation here, we've got HA plus BOH makes H2O plus Ba. So looking at what happens, this hydrogen here ends up bonding with the OH, which then leaves the B and the A by themselves to bond together. And that's how you get H2O and Ba. We have an example here, which is hydrobromic acid with sodium hydroxide. So the HBr plus NaOH makes NaBr and water. So the H bonds with the OH, the Na bonds with the Br. The key component to remember from this one is the fact that there's going to be an ionic compound and water. If you see those two things, you know that it's neutralization. Now let's talk about combustion. So this is when a hydrocarbon reacts with oxygen in order to form water and carbon dioxide. A hydrocarbon is anything that has hydrogen and carbon in it, hence the word hydrocarbon. In our generic equation here, we've got CXHY plus O2 makes CO2 plus H2O. So this is our hydrocarbon, and like I said up in the sentence above, it reacts with oxygen to make carbon dioxide and water. There can be other products on the product side as well, but if you see carbon dioxide and water, then most likely it's going to be combustion. So combustion reactions are an exothermic reaction, which means that they are giving off heat as they are occurring. Another example of the combustion reactions would be burning naphthalene. Naphthalene is C10H8. So this reacts with 12 molecules of O2 to make 10 molecules of CO2 and 4 molecules of H2O. The very important thing to remember is you're going to have carbon dioxide and water in your product always, always, always. So like I said, key point to look for when you're looking for combustion reactions is carbon dioxide and water. Alright, so here are some things to remember. If your reaction has oxygen as a reactant and carbon dioxide and water as a product, it's combustion. If your reaction has 2 or more chemicals combining to form one, that means that it's synthesis. If your reaction has one large molecule falling apart into smaller ones, then that's decomposition. If the reaction has any molecules that contain only one element, then it's single displacement. If your reaction has water as one of its products, then it's neutralization. And basically, if you haven't answered yes to any of the above, then you're left with displacement. So let's try some. If you want to go ahead and try these on your own, this would be the time to pause the video and come back for the answers when you're done. So CH4 plus 2O2 makes CO2 plus H2O. Remember when I said anytime there is carbon dioxide and water in the product, your equation is combustion. That's what this one is. You see that you have carbon dioxide and water in the product, but you also have oxygen and a hydrocarbon in your reactants. So that means this equation right here is going to be combustion. All right, let's look at the next equation. Pb plus O2 makes PbO2. We've got two reactants that end up becoming one product. That means this equation is a synthesis equation. Next one, we've got Fe plus NaBr makes FeBr plus Na. Okay, the Fe ends up bonding with the Br, and the Na ends up getting kicked out. So that would mean that this is a single displacement. And how we knew that was the fact that we had one element all by itself with a compound in the reactant side, and the fact that iron wasn't the element that came out by itself on the product side as well. Now we've got NH4OH plus HBr, which makes H2O plus NH4Br. Okay, we have water in our product, but I don't see carbon dioxide. So the only other equation that we had that had water in the product was neutralization. And the way to verify that is to look at the reactants and see if you have an acid and a base. Remember, acids have H plus ions, bases have OH minus. So if you see an H and an OH minus in the reaction on the reactant side, that's going to mean that this is a neutralization equation. And it looks like here I do see an OH and an H. So this is neutralization. All right, what about the next one? We've got CaSO4 plus MgOH2, which makes CaOH2 plus MgSO4. Okay, well, it looks like the SO4 and the OH are trading places. So that means that this is double displacement. All right, and for the last one, we've got Na2CO3, which makes Na2O plus CO2. So we have one reactant, which turns into multiple products. That would mean that this reaction is a decomposition reaction. So that ends the lesson for today. Email me if you have any questions, and hope you have a great day.